Hi, so I just thought it'd be helpful both for me and for communicating about the orb project to have like a working as I work on orb, I sort of have to make some decisions, or I sort of I'm learning about WebAssembly, and I sort of learn what the constraints are and what's possible, and so I thought it'd be useful to have some sort of like log or journal or workbook as I go along and think about and make decisions. So one of the little I make little demos. I'm not just sort of building a DSL or a little sort of language in isolation. I want to like solve actual problems. And so the you basic problem might be just how do I just work with some numbers and then do some calculations. And so I'm going bigger and bigger, getting like bigger and bigger problems, and then seeing how that can be solved. So many of the things that I'm looking at are like based around the web. So say if I want to have like a web server, um, you know, I want to have a send back a response with some sort of HTML. How might I model that? So I might have something that's gonna the WebAssembly module might expose an ability to get like a status code and an ability to read the HTML content, maybe the ability to read some headers, and so like those three ingredients. If I can work out how to like model them in this constrained WebAssembly world, um, yeah, then you can plug that into a system that actually is a HTTP web server and start serving requests. So one of the problems that I've been looking at is rendering a XML feed. So it's sort of just the same problem as HTML. So it's not that different. It's very similar problem. But one of the things that I want to do is like render a podcast XML feed, and so I've got some existing code that's in JavaScript, and I've worked out how to do this. I just have some data, an array of objects for all the episodes, and then I iterate over them, and I basically map the JavaScript object into XML. It's just XML is just markup. So it's just basically a lot of string interpolation, using the C data thing to escape the text contents in the XML. And so this is working. This is how the Runtime Reverie podcast is served. It's just a JavaScript function. All the episodes are just defined in a big array in JavaScript, and then they get mapped out into XML, and it's served as a web server. So, um, sort of as a as because I'm sort of just interested, sort of nerd site myself. I'm wondering how can I do this in WebAssembly. Um, and obviously, JavaScript. It's a very mature ecosystem. Things are a lot easier in that world. So one of the decisions that I'm illustrating here is I want to have the similar. Um, I want to have a similar workflow where the episodes get defined somehow, and then this WebAssembly module. What I want it to do is read from an external source of all the episodes. So I'm sort of working out how might I like iterate through the episodes, and then how would I then transform that into the XML output. So that stuff's actually been pretty simple. String interpolation's like not that hard. So basically, what I end up doing, here's my memory, and all I end up doing is just going like XML, blah blah blah. There's your XML tag. And then we're going to spit out like an RSS tag. It's going to be like version 2.0. And then there'll be some stuff like there'll be some more stuff, but there'll be like a channel, and then it's escaping my memory. I'll just look it up quickly. We'll have item. Thank you very much. We'll have I think it's a structure like this. I might have got it slightly wrong. Channel. Yes, there's a bunch of stuff in the channel, and then for each item, you'll have a bunch of content in there, and you know, here's a podcast feed with 3 items, and so that's the output that we want. And so from a WebAssembly point of view, if we just focus on this right hand side, WebAssembly point of view, all I want to do is UTF-8 encoding. I'm not sort of taking a shortcut for now, just sort of bladding stuff right through. I'm not validating that it's valid UTF-8 that I'm being given, but I just sort of assume UTF-8 in, UTF-8 out. And so in my WebAssembly's main memory, I'm going to end up with UTF-8 encoded this XML feed encoded like so, and so that works. And so UTF-8 is like such a common, it's like the standard way to encode text, and I actually don't intend on having any other ways of encoding or like any other programming language. Like whatever's running the WebAssembly module can just find this main memory, go, as long as it knows the start and the stop in the memory of where to read, it can extract out those bytes and decode that, and then it turns it into a string for the purpose of, it can do whatever it wants. It can send it back as a server response. So that problem's pretty easy. The tricky bit is I want these items to be dynamically to be dynamic. So if this thing gets instructed to render 4 items, I want it to render 4. If there's 3, it'll be 3. If there's 1, there'll only be 1. So I've got a system at the moment where this feed gets created, and this stuff just sort of gets appended in the main memory. There's only one single linear chunk of memory available in WebAssembly. And so the naive way that I've been doing things is that I just sort of literally append here. So I go, okay, append, and then the item's going to have a GUID, and that's the episode ID, so that might be 1, and so on. So we just keep appending to this memory, and so this is fine because we don't. There's nothing in the way. There's no other. Try not to use the word objects. We can sort of think there's nothing else on the heap. There's no other objects out there. I own the memory, so I can have confidence. I can just sort of keep extending the stuff down here. You can just keep appending to kingdom come. The problem is that one of the things that I want to blot out here is a description. And so this is like some HTML, and so it's dynamic in length, but I've got a problem because I want to use a system where I'm just appending, like it's like a string builder. This is what I call it. I'm just building the string here, but then the next piece of content here is going to be dynamic. And so I sort of have this one piece of memory that I'm owning. I'm just like owning the entire memory, and I can it's resizable because I can just keep appending. But then I kind of need this content here to be dynamically resizable as well, because this HTML content that's provided for the episode, like, hey, here's the show notes, this might be just simply say show notes, or it might be hundreds of lines of HTML. But that's a problem because now it's going to get in the way, because if I want to allocate any other memory, they're going to step on each other's toes. It's like one way of thinking about this is that the memory is like a big array, but there's only one array, and so I can't be both using the array to append the output and also be using the array to accept input. So it's quite a big problem that I have, and it's just one of those things where you sort of, in any other language, it's sort of solved for you because the memory allocator is provided for you, and so you don't even think about this. You just go, hey, give me allocate a thing of this size. If you're using, say, C, or if you're using like a more high level language, you just go, hey, I've got an array, just make it bigger now, and the system works it out. It might be able to just use the existing memory, might have to reallocate it and find something, a few more pages of memory to make room for it. It might use tricks where it doesn't have to be contiguous. So there's like all these sort of tricks, and they're nice tricks, but they get complicated. Okay, so so this arrow here, what's it intended to show is that when I am building out the string, I've just called this thing bump offset. And so if the memory is basically empty, basically just a bunch of zeros, then this offset starts as at 0. But as I build up here and say we're up to the next point to write out to is here, I'm not going to do the maths, but say it's 8F in hexadecimal. The hexadecimal is not really important here. We could say in decimal it's 129. So this number, the 6 characters here was previously 123, and then we write out item. We write this out. So 6 things get added, and then we add on 6, and now that's 9, and then it's gonna, as it adds more, this number's gonna keep going up and up and up. So this is how I keep track of basically where to write to memory next. It needs to live somewhere, and so WebAssembly has these things called globals, basically just global variables, and so this thing's just an int that I just keep, that I have control of. So yeah, the thing that the problem that I have is that, hey, I want to ask the parent for hey, give me the description of this episode right now. And so you can both have exported functions, and you can also import functions. And so the naming's all up to me here, but I might just sort of say hey, next episode. And so as we're building this stuff out, it's sort of not, this is just the memory, but if you can just sort of think of the mental model as that, hey, at this point in time when we're writing to here, we're going to call this next episode function. It's like a callback. So the parent thing, the host that's running the WebAssembly module, gets notified. It's able to implement whatever the hell it wants in this next episode thing. But it's basically a prompt to say hey, we're ready to write the next episode here. Inform me what the hell the episode description and title and timestamp and publish date and stuff is. So yeah, but then we have this problem, like I was saying, there's only one array of memory, and so how does it populate it? So yeah, one way is to have manually managed memory, and so we might have an alloc function that's going to be you can provide how many bytes that you want allocated. So you might say hey, okay, here's the next episode's HTML, and it's 100 characters. And so then what you're going to do is call the allocator with 100. It's 100 bytes. And so then that will spit back some sort of pointer. It's just basically an integer, but it's basically a pointer to, I'm going to reuse this arrow here and just delete this one. It's going to be a pointer. So this memory has to be allocated somewhere. So it might allocate it down here. This is the HTML, and it found room for it in the main memory somewhere, and put it there. And so this pointer, let's just say it's I don't know, 1080. This, we then say, okay, I've allocated that memory. The host then has a safe pointer it can write to, and the WebAssembly module knows how many bytes it expects to write to. So it's basically got free reign from 180 onwards for 100 more bytes. It's saying thumbs up, hey, you can go ahead and write the HTML into that space now. There's there's a space of 100 bytes here. It's all yours. And then what you might do is then say like, hey, set episode description, and this is going to be a pointer. So then what we'll do is that we might be just helpful to maybe just make another slide here. So here's what we're going to do. So the WebAssembly module, this is sort of, we're writing out our XML feed. We need the next episode. We call the host to ask for the next episode, which is, I think we called it next episode. The host then gets the episode description and of, let's just for example, it's 100 bytes. It asks the WebAssembly module to allocate 100 bytes and receives a pointer. It writes the episode description, which is HTML, 100 bytes to the pointer it has been given. The host calls, so this is the host here as well. The host calls a set episode description with that pointer, and then all's good. Now so everything, all this hard work was that now the WebAssembly can read the current episode's description. So the WebAssembly module, these callbacks can only be like integers back and forth. So there's no way to go like put the HTML here. It's just like literally like all we have access to is like an integer. Oh, we can maybe have 2 or 3 of them, but for an HTML document, it's going to be a lot of integers, and there's no possible way to actually pass all that data down. So all we've got access to is like a pointer, which is just an integer. So now the WebAssembly module, inside the module, all it's got ability to do is basically let's go back here. All it's got the ability to do is like read and write to its globals. It can call back out to functions that have been imported, and it has its own internal functions, and it has access to this big array of linear memory. So for anything long like this, like HTML of podcast description, it has to be in the main memory. Like that's the only location it can live. And so anything lengthy like that, the WebAssembly module can only read from its main memory. And so the host can also read and write to that main memory. And so this is like how this stuff gets communicated. So yeah, it's very limited, but it's it's very, very constrained. But then this is how you have to model all these problems to try and fit in this constrained space, which is my background as originally really more of a designer. I actually really like these constrained problems, so it's fun for problem solving. So anyway, back to here. So that was the process that we had, but there's a problem here which I described earlier, is that hey, I've allocated this memory. I could like allocate it all the way down here, make sure it's out of the way, but I want to keep like writing to this thing, and so at some point this thing's like going to steamroll over the it's going to steamroll over this thing here because it's just one big array of memory. It's all in the same space. It's all in the same house, and so at some point, as we get more and more items, at some point this is going to get overridden. And so I'm sort of thinking that here, like, we could technically know, because we know how many bytes this is going to be, so we could make safe that it's 100 bytes. We could do the maths to go like make sure that this is like at least 100 away from here, so we've got enough space. Because what we're going to end up doing is basically for our output, like basically paste that down here. And so we could do something like that. The other option is that this alloc, maybe it's not alloc, it's going to be like it. Yeah, maybe it asks, maybe it's not the next episode, it's the I want next episode description, please. Like, and maybe gets access to the description pointer. So it's like wants next episode description. Maybe it gets access to this offset here, and then maybe when instead of going set, maybe all this stuff goes away. And this is why this is useful for me to try and think out loud here. Maybe we give it this exact like position here, or we just put it on a new line here just to make it easier to read. Maybe gets access to this spot here, and then it's just able to blast it for us, and then it doesn't sort of know what came before, doesn't know what's going to come after, but it's sort of like, hey, fill this in, please. Yeah, that could work, because part of the problem is that I haven't mentioned here is that we're going to put HTML inside XML, so it's sort of like these things can't technically, these things will get recognized, this P here will get recognized as XML, and we don't want that. So what you have to do here is, I believe I'm getting this right, C data, that's slightly wrong syntax. The correct syntax is C with a open bracket, bang, C data, like this. I'm just going to put this on a new line here just so it's easy to read. So we could, our XML, put this here, and then it's like safe to put like whatever you want after there. There's a little caveat, the closing syntax is this, so as long as the HTML doesn't contain these 3 characters in the sequence, then it's safe. So this is, I don't think that's too bad an option. So the interesting thing here is that the WebAssembly module doesn't need to know, it needs to know the size of the thing. So I'm just going to try and make this wrap here. So this callback might say like, right back in I32 of basically how many bytes were written. So it's going to get access to it's going to call back at this point. We've written out the C data opening tag, and then we go like, hey, we want the HTML right now. It's going to call back the host saying like, for want of a better name, wants next episode description, and it's going to go give it this pointer here. So say this pointer is, I'm just making up these numbers. We're up to 843, whatever. This is 843 from the 843 here. So this will be past 843 here. And then the host implements his callback. It's going to conform by writing the HTML data at this point. Yay, show notes, blah, blah, blah. And then it's going to just return how many bytes that was. So I don't know, I'm not Rain Man, don't know how many that is. Let's say that's 19 bytes. So it's going to return like 19. So it's going to get 843. It's going to return 19. And so, yeah, I think this will work. And so then all the WebAssembly module has to do is go, okay, thank you, 19 bytes, that's fantastic. I bump offset, which is what this arrow should be pointing from. So it's 843 at the start. Calls out to the host, please write your HTML in here, blah, 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 fills it out. This pointer needs to be updated because then it's going to next write like the closing and closing for the description. So it needs to know where the stuff stops. And so that's why the host is going to return. Okay, just wrote 19 bytes. And so 60, this will become 62. It'll be 843 plus 19. So it's going to become 862. So I think this will work. The interesting thing is that we're sort of relying on, we can get away with this because we can safely write the HTML here. Because it just so happens that XML gives us a way to safely insert arbitrary HTML and have it be safe. Like, we don't have to escape the HTML, and so that really makes this convenient. If we had to escape this XML, which is another problems that I've tried to solve, is that we'll get given an input, but then the WebAssembly module like has to escape it or like do some processing or formatting, and then so you have to create like a copy, but we don't have that problem here, so that actually becomes quite simple. Like, I'm pretty happy with this. The other option that I thought I was going to be illustrating here, but I've ended up not needing to. The other option I was thinking of was you sort of have, I'll just duplicate this slide. So like this memory here in WebAssembly, it's linear, but what it really is these 64 kilobyte chunks called pages. Let's just give it a nice color. What about green? Orange. So it has these 64 kilobyte chunks of memory. 64 kilobytes. So if you want to have any main memory at all, you have to go right up to 64 kilobytes. You can't have like 4 bytes. You can't have 4 kilobytes. You can't have, hey, all I really need is like 1000 bytes. No, you have to go straight to 64 kilobytes. So that's a page. Page is like the minimum large chunk of memory that's allocated. So if you want more than 64 kilobytes, then you have to go 2 of them. And again, you can't have like a fraction. You can't have like 64 plus 32. Like, can't do that. So you have to, everything has to be in these increments of 64 kilobytes. And so you can, 3, 4, 6. So inside these little pages, and these are all joined together, so they're not standalone. But like inside this memory, that's where we're writing out our HTML output, and so it might get pretty long, so it might need multiple pages. So you can ask the WebAssembly sort of like system, like, hey, please another page of memory, sir. And so you might have, as you're writing out your HTML, you fill out this one, you fill up this one, and you go, oh, I've hit the end. It's not out of memory. I just ask the system for more memory, and it gives me another page. So you can just keep writing out to your heart's content. So yeah, the other option was I was thinking like, okay, here's my output, but maybe I actually like allocate other memory for other purposes. And so let's just give this a different color. That's too similar. Blue. Maybe have a couple of pages like put aside for different things. And so this is all linear. So this would be like offset 0 here, and then we go blah, blah, blah. This would be offset 64. Blah. This would be offset 128. Blah. This would be offset 192. And can't remember these numbers off the top of my head. But maybe like when I'm outputting, I start at offset 192 kilobytes. So this thing can like expand to its heart's content. But then I don't have that problem where it's going to like overwrite like some other memory that I wanted to have. Like, hey, I'm going to like let the host like write the episode description, but then it's like, oh shit, now we're stepping on each other's toes. So if you sort of like offset this stuff down and have a little headroom for other things to be worked with, then this thing can just like keep growing. It can only sort of grow forward. This thing can like take over the world, and we can get like megs and megs and megs of memory here, and it can keep going. But we're safe now because we sort of pre-allocated this memory before all this, so it's not going to be a problem. So this is the solution I was thinking of, and so this is what I was thinking, was that maybe I want to say like, hey, once next episode right now, please, as it's ready to write out the next episode. And let's just simplify this stuff. I want the next episode, please. And so what it would do is okay, I want the next episode, please. And then the host would go, okay, I'm being asked to provide the next episode. And then I go like, get episode description, like memory range. And then so this is going to basically return two numbers, one with the at the start of this memory. Let's just bring this to the front. One with the start of this memory and one with the at the end. It's probably easier if I just sort of maybe if I just sort of think of these as one-dimensional. So it's 64 kilobytes, and then so we at the offset at 64, and then end at 128, or maybe I just give it the length, whichever one. So the host probably already knows about the idea of pages, like the WebAssembly having 64 kilobyte pages is sort of built in. So probably maybe I don't even have maybe just sort of simplify it, just sort of say like, hey, get episode range. So this is going to return 2 ints. And it's going to basically say like, you're going to start at page 1. So this is page 0. You're going to start up at page 1, and you get one full page of memory to write to that. So we get 64 kilobytes. That this sort of memory here is sort of like we're giving this like little page a name of like, this is the description page. And so it's like allocated up front. And so been sort of following projects, describing Tiger Beetle. They allocate all their memory up front. Like all this is sort of set. They sort of have a full city plan of everything that they possibly will ever need, and then they never allocate any more memory. They never ask the system for like, hey, one more page, please. Like it's all, that's it. So it's all done at the very start of the program booting up, and that's it forevermore. So it's almost like designing a circuit board, like you're sort of working out where everything's going to fit ahead of time. So this is the idea I was thinking of, and I think I might like the other option better now. But yeah, here's what I was thinking. So it sort of gives you like a budget. So the sort of downside of this approach is that you only get 64 kilobytes. So if your episode description is longer than that, you're out of luck. But in some ways, I don't mind that because like 64 kilobytes for an episode description is like really long. I know like it's nice to make things sort of future proof, but that's a pretty good, I think that's a very generous budget, really. Like if you've got a podcast that's longer than that, I think you've done sort of something wrong. So that might be like a design, or like that's where I'm putting on my product hat. That's where I'm sort of thinking like maybe I think that's very reasonable to only have that amount. The other convenient thing is that like if it wrote out, it goes, okay, if we go to this other slide to sort of illustrate how this will work. So we're writing out XML feed. We're near the next episode. We go, hey, we go like, what do we call it? What next episode? It's basically the same concept. What next episode? The host then gets the episode description page range. We don't have to ask the WebAssembly module to allocate any memory. The host writes the description to the page that has been given. It must truncate the content if it is longer. So we had the one here, very abstract to know, but here's it's basically saying like from page 1, and you get a total of 1 page to work with. So here's page 0, here's page 1. It's like almost like this is almost like an array of like really big chunky boys. Here's page 4, here's page 5, and so on. So we're saying like, hey, from page 1, and you only get that 1 page. If we wanted to say like, hey, the description page, we actually want to give you like 128 kilobytes, then this might be say like, hey, this might be 2 here. So for some reason we think you need a bit more here. Our budget is now 2 pages, but like you can see here, like if it has to, the host when it's writing to that memory has to conform, because otherwise it's going to start overstepping here, because this is the next page that's right next to it. Like these pages are this is all linear memory, so this is like literally right there. So if it sort of did like a buffer overflow and kept writing, it would start to step on the toes here. So that's the contract it has to follow. So it must truncate the content if it is any longer. So that's it. So it fills that out in that callback of once next episode, and now the WebAssembly can read the episode description just like before. So probably what would end up happening here is it basically just is able just to copy. So this is our HTML output, XML output, blah, 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 blah. We just can do just a very naive copy of that page here. Maybe you do something like that. Chances are this won't be exact pages, so it'll be sort of more like at this particular offset here. It will you can sort of just black that in. So that's sort of interesting. So yeah, that was the option I was thinking of. So yeah, the sort of trade-offs here. The downside of this approach is that we get a budget, which in some ways is not bad. Like a lot of the AWS APIs have these very strict budgets of you, like in DynamoDB or SQS or whatever. Like you can't just put infinitely sized records into DynamoDB, and you can't have an SQS message that's like a terabyte. They have these very constrained sizes, and that like lets them optimize the system. It's just, and it seems to work for the developers, and so that's why I was leaning towards this option here. I don't think budgets and constraints like this are necessarily bad, but there's something tempting about this option here. It's also very simple. So yeah, I have to consider what to do here. So yeah, the downside of this one is that it's a budget. I think the downside of this one is it only works if it is able to use the existing content and doesn't have to like escape it. Like if we have to, for some reason, like do the escaping like this, like greater than, less than in HTML, then that's where this sort of starts to fall I think this approach doesn't work. But yeah, so might be sort of this solution might be sort of particular to um, this this particular problem. There's probably a way to like combine these two and do this like allocation the sort of pre-allocation up front, putting memory aside, but exposing this API. So that's the other option I'm thinking as well. Like I'm trying to keep these things pretty decoupled, so the host doesn't really know how the WebAssembly thing is implemented. It just has to implement these callbacks. So yeah, this is the thinking that I've been that I like to get involved in. So for like a pretty straightforward problem, sort of been quite surprising. It's been very educational, but just literally like reading a string and then concatenating strings. Like just such a simple problem in any other language. It gets tricky in this WebAssembly world. And so, yeah, this is sort of showing some of the constraints of what WebAssembly gives us if we're just at this very low level. But yeah, I enjoy the sort of problem solving. So that I've one of like the sort of two things that excite me particularly about WebAssembly for these sort of problems is one, it's very fast. I actually think like this will be like blazing fast. Like this stuff will just, no matter which option I do, it's going to be like really really fast. The second thing is that this code, these WebAssembly modules can run anywhere, and that's the thing that I'm really excited about with WebAssembly. Is like once I've implemented this, like whatever decisions I make, like it's all encapsulated in the WebAssembly module, and then your contract to the host is you just have to implement these callbacks. Once that's done, like those hosts can be the browser, can be mobile, can be the server, can be the edge, and so that's what I'm really excited about. Is once I've worked out how to solve different flavored problems, yeah, we can start to like run the exact same code to say output HTML or output an XML feed and have it run everywhere. It's sort of a little bit of logic to the right once run everywhere statement, because it's just it it's just a bit, it just sort of fails a bit. But the thing I'm looking at is like these are just modules. You're not writing your whole entire application. It's just like this little module, almost like a little library that you normally search for in your package manager. Oh, I want to make a RSS feed, and so I find the RSS library in C# or JavaScript or in Rust or whatever to do this. I would like to have a thing with these WebAssembly modules where it's solved in WebAssembly, and then it doesn't matter what your host language or your host platform is. You can just plug these in and it'll just work. And so that's the dream that I'm working towards. So yeah, thank you for watching this video. I'm going to make more of these, and yeah, if you're interested in any of this stuff, check out the Orb open source project, which is how I'm implementing all this. It's a DSL using Elixir, which is like a modern functional language with macros and all sorts of stuff. And that's how I'm implementing this stuff. I'm trying to make the WebAssembly stuff, we're like at a very low level here, but I'm trying to give it a friendly, lot of conveniences and stuff in the friendly language with existing Elixir tooling. So yeah, feel free to check out that project, and I'll be sharing some actual code as I work out how exactly I want to solve this problem.